Good morning, ladies and gentlemen. Today is November 30th. I am at a dentist appointment, so I'm not currently able to be with you, but here's a brief rundown of what we are going to be learning. Before we went on break, and before we spent our fun day playing jackpot games, we learned about quadratic functions. So I'm just going to review that. If you remember how to do it, you can go ahead and move on to the DOL and homework for the day, which are DOL 3.1a and homework 3.1a. Otherwise, stay tuned and I will go over this lesson again. So, we are on Module 3, Lesson 1. If you are looking for what we're working on in Connect Ed, again, you can find a lot of examples in there. They have immediate feedback for the practice problems so that you can know if you are doing them correctly or not. If you do have questions, take a look at the new schedule for my office hours, and you can join me in my Teams meeting to ask questions there. But without further ado, the quadratic function has an equation in the form seen here, ax squared plus bx plus c. Now, what makes it a quadratic function is this squared right here. Its highest exponent is squared. So, note that in a quadratic function, the greatest exponent on the independent variable, aka x, is 2. So, anytime our highest exponent is 2, we know we've got a quadratic function, and I know it's covered by that Doceri logo, but quadratic functions make this U shape that we see over here. This is called a parabola. Now, the shape and location change depending on the equation, but they should always form this parabola. All right, there are some key characteristics of quadratic functions that we can look at. Namely, the ones that we are going to be focused on for now are the y-intercept, which can be found by substituting 0 for all x values and then solving for y. So they'll give you an equation. If you plug in 0 for x, for all x's, let me put that, all x's, then get y alone. This will give you your y-intercept, or it will tell you where our graph touches the y-axis. In our equation, ax squared plus bx plus c, the c value is actually always going to be our y-intercept. So sometimes it'll be negative, sometimes it'll be positive, but both of these are good ways to find your y-intercept. Okay? Now, the axis of symmetry can be calculated using this equation. X equals. Now, you have to write this x equals in the front. If you do not write it, you are going to be counted as incorrect. The axis of symmetry is a line, and in order to build a line, you have to have an equation. So you need x equals. I know it says y equals over here, but that's a typo. So it should say x equals. But to find the axis of symmetry, you take your negative or your opposite of b. Let me underline that in green. B is right here. It will always be right in front of x. So the negative version of b, or the opposite of b, divided by 2 times whatever a is. And a is always the coefficient of x squared. If you don't see anything in front of x squared, remember there's a 1 there. So 2a, negative b over 2a, is how we calculate our axis of symmetry. The axis of symmetry is this line that kind of goes through the middle of the parabola and makes it a mirror image on the left and the right. It makes it symmetrical on the left and the right. And I know it's a little bit hard to see with this logo here. However, one last key characteristic we talked about is called the vertex. And the vertex is down here in this particular graph. The vertex is always the highest or lowest point on your parabola. Axis of symmetry. Now, your axis of symmetry always crosses your parabola at the vertex. So, in order to calculate the vertex, you just have to find a y value for it, because the x value from this is the x coordinate of your vertex. So to find your vertex, plug in the AOS, which is abbreviated for axis of symmetry, and I'll even do that in orange since that's what I have been using for axis of symmetry. You plug that in for your x values, then solve for y. So when you're done, you're going to get a coordinate. Again, the y value of your coordinate is going to come from plugging it in and then solving. So I'll call that f of AOS when you plug the axis of symmetry into your function f. And your x value is going to be just whatever your AOS was, your axis of symmetry. For your coordinate, you don't need to write the x equals in front of it, because we don't write x equals in front of coordinates. But these are the three pieces that we'd be focused on today. So I'll go over an example, and then I will let you work on the assignment work. Okay, so I'll go over an entire graph. They want us to graph x squared plus 2x minus 3, and then determine the domain and range. So to find the x-intercept, or I'm sorry, the y-intercept, I remember that it is as simple as looking for the c value. And I notice that it is -3. So my y-intercept, I can write as 0, -3, or as just y equals -3. And I'm done with that part. The second thing they want is the axis of symmetry. Again, that was x equals -b over 2a. -b over 2 times a. Where again, a is the number in front of x squared, if we see one, and if we don't, it's a 1. And b is the number in front of just your regular x. So in this case, it looks like my a, I don't see anything in front of x squared, so my a is just a +1 since it's a positive x squared. And my b looks like it's +2, so b is a +2. I'm going to go ahead and plug those into the equation. Negative b, which is 2, over 2 times a, which is 1. I get -2 over 2, or just -1 if I simplify it. So the correct way to write my axis of symmetry would be x equals -1. And now we are done with the axis of symmetry. Now that we found the axis of symmetry, we're going to find the vertex by taking -1 and plugging it into the equation. So what this looks like is, instead of x squared plus 2x minus 3, everywhere I see an x, I'm going to plug in that -1. So instead of x squared, I'm going to plug in -1 squared plus 2 times x minus 3. And again, that x was -1, so I'm going to plug in 2 times -1 plus 3. -1 squared is 1. 2 times -1 is -2. I'll do this in purple. Minus 3. 1 plus a -2 is a -1. -1 minus 3 is -4. So that tells me my vertex is at the coordinate -1, because that was my axis of symmetry. And when I plugged it in, the answer that I got out was -4. So here is my vertex. All right. So I'm going to do every 3 lines. 1, 2, 3. 1, 2, 3, just so that we can see better. It's -1, -2, -3, -4. Up and down as well. Counting. Yeah, close enough. All right. So just so that the picture isn't so tiny and I don't have to write so small. All right, it looks like my y, now that I'm graphing it, sorry, my y-intercept is at -3. So I'm going to plot that point on the y-axis. I put a point at -3. 1, -2, -3. Okay. I already don't like this, but that's okay. My axis of symmetry will be at -1. So at -1, I'm going to do a dashed line just to visualize what my axis of symmetry looks like. So I know that my graph is going to be symmetric with this orange line. So as a matter of fact, since I see that this point is 1 away, I can also go 1 away, figure out what another point is, but we'll get to that whenever I actually plug it in. And I also know, that my vertex is -1, -4. So I go left 1 and down 4, and that is where my vertex is. To find other points for my graph, you can just plug in different numbers into your equation. So in this equation, I'm going to plug in some different values. Since I know that my axis of symmetry, or the middle of my graph, is at -1, I like to put -1 in the middle, do two numbers that are below -1, aka -2 and -3, and then two numbers that are above -1, which are 0 and 1. Now I'm just going to evaluate these. -3 squared plus 2 times -3 minus 3. That's 9 plus -6, which is 3. Minus 3 is 0. I'll do these points in green. So I get -3, 0 is 1 point. I plug in -2. 4 minus 4 is 0. Minus 3 is -3. -2, -3. I plug in 0. 0 squared plus 2 times 0 is 0. 0 minus 3 is -3 again. We can see that symmetry right here, how they ended up being the same number. And then finally, using symmetry, I bet it's going to be 0, but we'll check. 1 squared is 1. 2 times 1 is 2. 1 plus 2 is 3. Minus 3 is 0. Yep, 1, 0. So I'm going to plot these new points, -3, 0, -2, -3, which is, again, that symmetric point that I was talking about earlier. We already have -1, -4, because that's my vertex. We already have 0, -3, because that's my y-intercept. And then we have 1, 0. So we notice this is 1, 2 away, and so is this. We're symmetric with that line in the middle, so our point should always be the same distance from each other. But when I connect these dots, I know that logo is getting in the way, so sorry about that. But we can see the parabola that it makes. Okay. So you've got some practice problems. Try these out. Read through them, experiment with them. If you have any questions, feel free to ask during my office hours. Again, these questions can be found on Connect Ed. You can do different problems. Don't worry about these word problems. We are probably not going to get to those. They involve finding maximums and minimums. You can try them if you'd like to, by all means, but I'm not going to make you do them. As long as you can find the y-intercept, the axis of symmetry, and the vertex, I am happy with that. So please make sure that you try the DOL in homework, and if you have questions, see me. Again, we are on module 3, lesson 1, and we are doing DOL and homework 3.1a. All right, have a great day. I suppose I shall see you on Wednesday.